Before we plunge into the declaration, it's essential to comprehend what molecule gas pedals are. The Enormous Hadron Collider, LHC, worked by CERN, is a 17M ring of superconducting magnets and the world's biggest and most impressive atom smasher. It addresses the zenith of human logical accomplishment. Truth be told, it's strong to the point that it can reproduce the actual states of the universe's introduction to the world. Yet, could this machine, intended to open the mystery of the universe, hold the way to something undeniably more unfavorable? CERN, established in 1954, is one of the world's most lofty examination associations, with 23 part states and a huge number of researchers. It fills in as a center for joint effort and innovation. The LHC is CERN's leader project, yet it's only one piece of a tremendous organization of gas pedals and trials. Envision a circuit not so much for vehicles or ponies, but rather for subatomic particles in a test of skill, endurance, and space itself. The LHC speeds up protons to almost the speed of light, sending them on a crash course that emulates the energy of the universe at the hour of the big explosion. These impacts create temperatures multiple times more sweltering than the center of the sun. Great many magnets guide the protons on their excursion, while mind-boggling cooling frameworks keep the magnets at temperatures colder than space. The shafts inside the LHC are made to crash at 4 areas around the gas pedal ring, corresponding to the places of 4 molecule identifiers: Mapbook, CMS, ALICE, and LHCb. Each fills an exceptional need, investigating various parts of molecule physical science. Together, they go about as gigantic cameras, catching depictions of these crashes. Researchers then scan through the flotsam and jetsam, searching for indications of the slippery Higgs boson, otherwise called the God particle, and different peculiarities that offer hints to the universe's major structure blocks. By concentrating on the microcosm, we gain experiences into the cosmos. Yet, with each answer comes another inquiry, and with each disclosure, another test. The LHC isn't simply a logical instrument. It's a demonstration of human interest and advancement. It typifies our determined quest for information and our longing to grasp the fundamental forces that shape our universe. Yet, as we push the limits of what we realize, we must also consider the moral and existential inquiries that emerge. What are the dangers of examining the obscure? Might our journey for understanding, coincidentally, open powers we have zero control over? In the consecrated halls of CERN, where the limits of human comprehension are continually pushed, a discovery has arisen that sends a shudder down the spine of even the most prepared researchers. Brian Cox, a former scientist at CERN and a voice of expertise in the realm of molecule physical science, has as of late made a declaration that has left the world both entranced and unfortunate. Cox's words reverberate with tormenting clarity. The objective of CERN's Enormous Hadron Collider is to reproduce a small Big Bang. Yes, you heard that right. A little adaptation of the very occasion that brought forth our universe. The physicist likewise proceeded to make sense of the ramifications of this objective, highlighting the LHC's unprecedented potential for making new discoveries. This includes its capacity to open the insider secrets of the Higgs boson and investigate dark matter, a baffling substance that makes up a critical piece of the universe. Envision grasping the force of creation, the capacity to summon the very essence of the universe. It's a tempting possibility, yet one full of peril. The scaled-down Big Bang isn't a hypothetical idea, it's a substantial reality. Inside the LHC, the temperatures, the tensions, the crude energy, all copy the states of the universe's outset. It's like remaining at the beginning of recorded history, witnessing the birth of existence itself. Yet, with such power comes responsibility, and the question looms, what if something turns out wrong? As a matter of fact, something did turn out wrong back in 1978. The Russian physicist Anat Borsky experienced a debacle that would perpetually modify the direction of his life. While chipping away at the U-70 synchrotron at the Institute for High Energy Physics in Russia, a glitch led to his head unintentionally coming into the direct path of a proton beam. The beam, with a power that defies comprehension, went through his skull, entering the rear of his head and exiting through his nose. Borsky's experience was supernatural. He saw a blaze brighter than 1,000 suns, yet had no worries. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, incredibly, Borsky's intellectual abilities remained intact, and he continued his scientific career. This incident isn't just an individual misfortune but a useful lesson that highlights the massive power and potential danger of particle accelerators. The risks of an atom smasher like the LHC are not to be trifled with. The potential for unanticipated reactions, the very fabric of reality being altered, these are not the stuff of sci-fi but real concerns voiced by some mainstream scientists. One of the most disturbing and entrancing concerns related to the LHC's trials is the chance of creating a small black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are vast vacuum cleaners, devourers of stars, confounding elements that prowl in the shadows of our universe. That the LHC could create such a substance, even on a minute scale, is terrifying to both the public and scientists alike. Could this black hole someday grow wildly, swallowing the Earth from the inside? However, researchers at CERN have assured that any black hole created would be unstable and vanish instantly. The remote chance has sparked debates, fears, and a sense of wonder at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the key mechanics of particle accelerators. When protons are smashed together at almost the speed of light, the energy released is so great that it bends the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends, and, if the weight is heavy enough, it could create a depression so deep that anything nearby would fall into it. That's a complex analogy for what could happen in the LHC. In the world of quantum physics, where the laws of the universe are both strange and beautiful, there exists a theory that additional dimensions might be hidden within our reality. If these dimensions exist, the LHC's crashes could tap into them, creating a gravitational well that forms a minuscule black hole. This mysterious dance of particles has even grabbed the attention of several highly renowned scientists, especially the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that wouldn't just destroy the Earth but the entire universe. The respected English cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN in his book on the future, Prospects for Humanity. He explored the potential dangers associated with particle accelerator experiments, including those at CERN. His words were not merely precautionary, they were laced with a sense of existential dread. He discussed a worst-case scenario where a failed experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, resulting in an unimaginable catastrophe that could engulf the entire universe. Rees's concerns were not limited to theoretical ideas. He assigned a low probability to these disastrous outcomes, but even a microscopic change, he argued, should give us pause. The stakes are impossibly high, and the margin for error is razor-thin. The researchers at CERN have run the simulations, examined the theories, and defended the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible research, recognizing that there are widespread fears and concerns surrounding the activities at the LHC. He emphasized that there are stringent safety measures in place, thorough reviews and protocols that ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally experiences, and the chances of creating a stable black hole are cosmically low. Even if one were created, scientists say it would be so small and so unstable that it would dissipate instantly, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. It would be a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's investigations could open a portal to another universe or dimension. This idea, though generally dismissed by mainstream scientists, has captured the imagination of many and has become a topic of interest, fear, and even mythology. What lies beyond our reality? Might we accidentally unleash forces or entities that we don't understand, opening a gateway to hell? This concept has even been sensationalized in various media, fueling the fire of uncertainty. But how did this idea arise, and what does it mean in the context of scientific investigation? The concept of parallel dimensions is not new in physics. String theory, a leading contender for a unified theory of everything, suggests that there might be more than the familiar three dimensions of space and one of time. These additional dimensions could be compactified or hidden. String theory proposes that these extra dimensions, though hidden from our everyday perception, might exist at very small scales. In some versions of the theory, these dimensions are tightly curled up, far beyond the reach of current technology and our ability to detect them. The LHC, in its quest to explore the fundamental particles of nature, could be the key to revealing these dimensions, if they exist. When particles collide at nearly the speed of light, the energy involved might be sufficient to probe these hidden realms, potentially opening up a new frontier of understanding in physics. This idea raises profound questions. What would it mean if we were to uncover these dimensions? Would they be the key to understanding the true nature of reality, or could we inadvertently uncover something much darker, forces that are far beyond our control? Could we, in our quest for knowledge, accidentally cause irreversible changes to the fabric of the universe itself? The scientific community remains divided on these possibilities. While some scientists express caution and recognize the immense risks, others remain more optimistic, pointing to the rigorous safety measures in place at CERN. The LHC has undergone extensive evaluations to ensure that its experiments do not pose a threat to our planet. Yet, the potential for unforeseen consequences, no matter how small, continues to fuel debates about the ethical implications of such cutting-edge research. One of the most debated topics is the idea that the LHC could create conditions that lead to the formation of strangelets, hypothetical particles that are more stable than ordinary matter. If strangelets were created in the LHC, there is a possibility that they could convert normal matter into strange matter, potentially creating a chain reaction that could alter the composition of the entire planet. While the likelihood of this occurring is extremely low, it is a concern that has led some scientists to call for greater transparency and caution in the LHC's operations. Despite these concerns, the majority of the scientific community remains confident that the LHC is safe. The potential benefits of this massive scientific endeavor, uncovering the mysteries of dark matter, the Higgs boson, and the very origins of the universe, are immense. It is a testament to humanity's unyielding curiosity and desire to understand the cosmos. At the heart of these debates lies a fundamental truth. Science, by its nature, is both a pursuit of knowledge and a potential source of power. As we push the boundaries of what is known, we must also recognize the responsibility that comes with this knowledge. The LHC is a tool, a creation of human ingenuity that has the potential to unlock new dimensions of understanding. But with that power comes the ever-present reminder that there are risks we may not fully comprehend, risks that could change the course of history. The questions raised by the LHC are not just scientific, they are philosophical and existential. What are we willing to risk in the pursuit of knowledge? How far are we willing to go in exploring the unknown, knowing that there may be dangers we cannot anticipate? The future of the LHC, and similar research endeavors, may ultimately come down to finding a balance between exploration and caution, between discovery and the preservation of what we hold dear. As the LHC continues to probe the fundamental forces that shape our universe, the scientific community will continue to monitor its progress, assessing the risks and rewards of this groundbreaking research. And as we stand on the precipice of understanding, we must remember that with each discovery comes the possibility of even greater mysteries, and with each mystery, the potential for even more profound questions about the nature of existence itself. As the LHC continues its journey, it serves as both a symbol of human achievement and a reminder of the vast unknowns that lie before us. Every experiment conducted, every collision of particles, is not just an exploration of the microcosm, but an invitation to probe the very nature of existence. In this pursuit, the scientific community faces a profound challenge: how to balance the thrill of discovery with the responsibility to carefully consider the potential consequences. The search for answers to fundamental questions about the universe, such as the nature of dark matter, the Higgs boson, and the very origins of the cosmos, is undeniably important. These discoveries could reshape our understanding of physics, revealing how the universe came to be and what drives its fundamental forces. Yet, the questions about the risks involved cannot be easily dismissed. What if the forces we tap into exceed our understanding? What if, in our pursuit of knowledge, we unintentionally awaken forces that are dangerous, forces we are not prepared to handle? These concerns are not lost on the scientists working at CERN. They are aware of the potential hazards and have implemented extensive safety protocols to ensure the responsible conduct of experiments. In fact, CERN has taken measures to study and model potential risks, from black holes to strangelets, with a focus on addressing any concerns that may arise. Experts have conducted a wide range of simulations to calculate the probabilities of various scenarios, and all results point to the safety of the LHC. Yet, The fact that we are dealing with such unknowns keeps many people on edge, raising the question, can we truly anticipate all possible outcomes? What makes this dilemma even more complex is the nature of scientific progress itself. In the history of science, there are numerous examples of groundbreaking discoveries that were initially met with skepticism, fear, or even opposition. The discovery of electricity, the splitting of the atom, the advent of the internet, all of these innovations reshaped society, sometimes in ways that were not immediately clear. The LHC and its potential for uncovering hidden dimensions or unlocking new forces are simply the latest in a long line of endeavors that push the boundaries of our knowledge. In the end, the story of the LHC is not just about particle collisions and the search for the Higgs boson. It is a story about human curiosity, ambition, and the unyielding desire to understand the universe at its deepest level. It is a testament to the incredible achievements of modern science, but also a reminder that with great power comes great responsibility. The future of the LHC, and similar experiments, will undoubtedly continue to be a topic of debate and discussion. Some will always question whether the risks outweigh the rewards, while others will remain focused on the potential for new discoveries. What is clear, however, is that the questions raised by these experiments are not just theoretical, they have real implications for our understanding of the universe and our place within it. As we continue to unlock the secrets of the universe, we must do so with a sense of humility and caution. Science is not just about discovery, it is about understanding the broader context in which these discoveries occur. Each breakthrough must be followed by careful reflection, with consideration for the ethical, existential, and practical consequences. The LHC and its ongoing experiments are a powerful reminder that we are still at the beginning of our journey to understand the cosmos. The mysteries of the universe are vast, and our ability to comprehend them is still growing. But as we look to the future, we must remain mindful of the challenges that lie ahead, both in terms of the science itself and the questions it raises about the nature of knowledge, power, and responsibility.